Assalamualaikum and hi, my name is Sofia Amira and I'll be presenting the introduction of electronic and microelectronic industrial processes, which is the definition of industrial process, industrial hazards and the importance of hazard study. Industrial process can be defined as method or procedure that use electronic device and system to control, automate and monitor machinery and operation within the industrial setting. These processes are fundamental in heavy industries. Next is industrial hazards that can be defined as dangerous condition that can pose a risk of injury, illness or property damage to workers and environment. Lastly is importance of hazard study is to prevent accidents, protect workers and ensure operational continuity by mitigate hazards and potential risks.
Next, hazard identification. First of all, we have physical hazard. Electronic and microelectronic produces various physical hazards, primarily stemming from the use of electricity, radiation, machinery and extreme temperatures. These hazards can occur during manufacturing, maintenance and typical use. So, first of all, electrical hazard, which is electric shock and electrocution. So, contact with live circuits, damaged wire or faulty equipment can result in current flowing through the body, causing injury, burns, cardiac arrest or death. Next, mechanical hazard, which is moving parts. Unprotected moving parts can cause cuts, crush injuries or amputations. And then we have radiation hazard, which is ionizing radiation. Sources like X-ray and gamma rays used in manufacturing or present in space environments can damage human cells and lead to cancer or tissue damage with prolonged exposure. Lastly, noise and vibration. Machinery such as motors and cutting equipment can produce noise levels that may cause temporary or permanent hearing loss over time. Vibration from tools or machinery can lead to hand-arm vibration syndrome or other problems. Next, chemical hazards. Chemical hazards in the electronic and microelectronic industry appears at various stages, from manufacturing to recycling. These hazards come from heavy metals, acid and bases, toxic gases, and organic solvents or pollutants used in different processes. First, acid and bases such as sulfuric acid, nitric acid, phosphoric acid, hydrochloric acid, ammonia and potassium hydroxide. They are used for cleaning and etching. These substances are corrosive and can cause burns, eye injuries and breathing problems. Next, heavy metals such as lead, mercury, cadmium, chromium, nickel, arsenic and copper used in soldering and wiring. Long-term exposure can cause nerve damage, skin problems and kidney issue. Thirdly, we have organic pollutants and solvents. Solvents like isopropyl alcohol, acetone, benzene, toluene and xylene are used for cleaning and degreasing. Exposure can lead to dizziness, skin irritation and long-term organ damage. Lastly, toxic gases. Gases such as arsine, phosphine, xylene and chlorine are used in a semiconductor production. They are poisonous and flammable, and even small leaks can cause serious health effects or explosion. Next, biological hazards. Biological hazards are less significant compared to other risks, but contaminated cleanroom environments or air conditioning systems can still pose a threat. For example, we have heavy metals, which is workers may be exposed to metal dust and fumes through inhalation or skin contact during material handling and processing, leading to potential metal poisoning and various chronic disease. Secondly, toxic gases. The use of dopant gases such as arsine and phosphine in semiconductor fabrication can be extremely hazardous if leaks occur, potentially causing severe organ damage. Thirdly, we have environmental contamination, which is heavy metals and persistent organic pollutants, POPs, contaminate air, soil and water, entering the food chain and accumulating in living organisms. Lastly, chemical exposure. Processes such as etching and plating use toxic chemicals like organic solvents and strong acids. Exposure can cause skin and eye damage, respiratory problems, central nervous system damage, and various cancers. Fourth, we have agronomic hazards. So, agronomic hazards in electronic and microelectronic industries primarily involve physical and psychosocial factors that lead to musculoskeletal disorder (MDRs) and repetitive strain injuries (RSIs). So, first hazard we have poor workstation design, which is inappropriate workstation height, lack of adjustable chairs, and inadequate space can force worker into awkward posture. Next, we have prolonged sitting or standing. So, both can be hazardous if not managed properly. Prolonged standing can lead to lower limb pain, while prolonged sitting without adequate back support or movement contributes to back and neck pain. Next, repetitive motions. Tasks involving the assembly and inspection of small components require frequent, repetitive movements of the hands and fingers. This can lead to cumulative trauma disorder like carpal tunnel syndrome, tendinitis, and trigger finger. So lastly, we have vibration and temperature extreme. So use of vibrating tools can contribute to upper limb disorder. So working in environments that are too cold can reduce dexterity and blood flow, increasing the risk of injury.
Next, we have risk assessment. It's a process used to identify and evaluate hazards found in the industry. Through this process, we determine the likelihood of a hazard occurring and the severity of its consequences. Next, we use a risk matrix to classify the level of risk as low, medium, or high. The result of the assessment helps us decide the appropriate control measures needed to reduce or prevent the hazards. Overall, risk assessment ensures a safer workplace and protects workers from potential harms. This slide shows the guidance for the risk matrix scale. First, the likelihood rating. Number 1, which is rare, unlikely, possible, likely, or almost certain. Next is the severity scale, which is insignificant or minor injury, minor but reversible injury, moderate injury or short-term illness, or fatality or permanent disability. But multiplying likelihood and severity, we get the risk level, which is 1 to 5, which is low risk, 6 to 10, medium risk, 11 to 25, which is high risk. These metrics help us quickly understand how serious a hazard is and how urgently it needs to be controlled. This slide shows example of risk assessment in the electronics and microelectronics industry. Number 1, which is physical hazard, electrical shock or UV light from high voltage systems. Likelihood, which is 4, severity is 5, risk rating is 20, which is kinda high risk. This can cause a fatal shock. Number 2, which is chemical hazard, exposure to toxic gases such as HF, phosphine, or arsine used in etching and doping. Likelihood 3, severity, which is 5, risk rating 15, which is high risk. These gases can cause serious respiratory damage. Number 3, which is biological hazard, which contamination from clean room system or waste discharge. Likelihood, which is 2, severity 3, risk rating is 6, which medium risk. This may affect workers' health. Number 4, which is ergonomic hazard, repetitive motions or poor workstation design. Likelihood 4, severity, which is 3, risk rating is 12, which is high risk. This can lead to musculoskeletal disorders. lastly, we have psychosocial hazard. High workload and job stress. Likelihood, which is 3. Severity, which is 3 also. Risk rating, which is we combine together, which is 9, which can cause medium risk. This also can cause fatigue and anxiety and requires proper management and job rotation. This example shows how different hazards are evaluated and why suitable controls must be implemented.
Next is hazard control measure. We have physical hazard, which is electric shock and electrocution. Based on hierarchy control, first elimination, remove faulty or unsafe wiring electrical equipment. Second is sublimation, use low voltage tool where possible. Third is engineering control, install insulation, circuit breaker, grounding and emergency shut-off switches. Fourth is administrative control. We conduct regular inspection, maintenance and electrical safety training. Last but not least is PPE, personal protective equipment. Use insulated glove, boot and safety helmet. Next is chemical hazard, which is heavy metal. Based on hierarchy control, first elimination, avoid use of toxic metals where possible. Second is sublimation, replace lead, cadmium or arsenic with the safer materials. Third is engineering control, use local exhaust ventilation, enclosed handling. Fourth is administrative control, provide and monitoring medical surveillance, hygiene rules like no eating or drinking in the work areas. Lastly is PPE, personal protective equipment, use glove, respirator and protective clothing.
Next control measure is biological hazards. The environmental contamination. By following the hierarchy of controls, we can use eliminate, which is stop discharge of pollutant into the environment. Sublimation, which is replace persistent organic pollutant with biodegradable or non-toxic materials. And engineering controls, which is use closed loop system, proper waste treatment and containment structures to prevent leaks. And lastly, administrative controls, which is monitor air, soil and control quality and maintain waste management records, train staff in environmental safety. And lastly, the PPE, which is provide gloves, boots and protective suits for waste handling. Furthermore, the control measure for ergonomic hazards, which is poor workstation design. By following the hierarchy of control, for elimination, we can redesign tasks to avoid awkward position entirely. And sublimation, we can use adjustable ergonomic furniture and equipment. And thirdly, engineering control, we can provide high adjustable desk or chair and monitor stand and adequate workspace. And fourth, administrative control, which is we can train workers on ergonomic setup and posture, perform ergonomic assessment. And lastly, the PPE, we can provide wrist support or cushion if needed. Last control measures in this video, which is psychosocial hazards, high pressure and work overload. By following the hierarchy of control, firstly, elimination, we can redesign workflows to balance workloads. And second, sublimate, we can automate repetitive or time-critical processes. And third, engineering controls, we can improve workflow system to distribute tasks evenly. And fourth, administrative control, we can provide realistic deadlines, stress management training and adequate staffing. And lastly, PPE, which is not applicable for this hazard.
Next is conclusion. Based on report, we found that the biggest dangers in electronic work are shock, toxic materials, and muscle strain. By fixing this problem can be expensive and hard, so the best plan is to understanding and practicing electrical safety is vital to protect ourselves and our environment from electrical hazard. Last but not least is recommendation. So this recommendation is to keep workers safe. First, build safety in from the start. Second, use a safer machine. Third, create a safety first culture. Fourth, offer health checkup. And lastly is improving the workplace. By doing all the recommendation, we could reduce all the hazard that might be happen in the workplace, work areas or workers that related to electric and microelectronic industrial process.